I didn't know what I'm getting into when I agreed to this. But, you know, I had a great team. So the people that you see here, they were all involved in putting this paper together. If you have any specific questions at the end of my talk, I probably won't be able to answer them because, again, I had a great team of all kind of expertises. Most of these are animal scientists, but we had soil and plant. And of course, Art was heavily involved in the climate predictions part of our talk. So my job is pretty simple. I'm going to present the paper that we wrote in climatic change. My slides are not nearly as exciting as the slides that you just saw from Dave and Art. So as the first speaker said, don't try to read my slides. I'll summarize it to you because there is a lot of text there. This is the states that were included in the work that we did, the survey, including West Virginia. First, we looked at the structure of livestock, and I'll remind you here what these industries look like in the Northeast. Dairy is the main industry. We estimated about $7.5 billion industry. In the Northeast, I think it's the main agricultural industry overall, at least in Pennsylvania is. Poultry is a big industry as well, second in Pennsylvania for sure. It's estimated around $4.5 billion. There is beef animals, beef industry, that's not very significant here in this region. And horse industry, equine industry is also big for a lot of different reasons, and that's also an agricultural activity, and we included it in this analysis. It's estimated around, these numbers are a little more difficult to come up with, so between 1 and 4.3 billion dollars. There is also sheep, goats, small ruminants, swine in the region. I'm not going to talk too much about this because these are very small, relatively small industries in the region. First, the dairy industry. It's a major industry in several states. Vermont, actually, 68% of the farm receipts. New York, 50+%. Pennsylvania, about 30%, and so on. Milk production is 14 billion kilograms per year, 14% of the U.S. total. New York ranks 4th in the country. Pennsylvania is 5th by total milk production. A lot of the organic milk production is also here in the Northeast, about 20% of the total. Let's see what else here. There is about 1.4 million cows, dairy cows here in the region. So that's a significant number of animals. The farms are small, and this has some implication of what we are going to talk about here. As you see, they're about 1-2% smaller than 50 cows. In Pennsylvania, the average herd size is about 75 cows. On average, the median average for the region is about 200 cows. But these are relatively small farms compared to the Midwest or the West. The poultry industry is concentrated, so there is a lot of large operations on the broiler side. About 99 or almost all of the broilers are produced on the large farms with over 100,000 birds. The egg industry is also concentrated. Small number of farms, less than 1% of the operations provide 84% of the layers inventory in the region. There are some states with major poultry production. They are listed here. We can skip this. I also want to mention that there is a significant turkey production and also organic turkey production, not just overall turkey production in the Northeast. Equine is a little more diverse, and for this analysis, we came up with 716,000 horses in the Northeast, and that number is very fluid. We were not able to come up with a real solid number because different surveys give you a different number. So on average, we came up with this 700,000 plus horses. Represents about 10 to 11% of the national horse population. It's used for different purposes, recreation mainly, 40%, showing and racing, smaller percentages. Pennsylvania, New York, Maryland, and so on, they represent most of the horses in the region. So Art talked about this. I'm gonna pretty much skip it, but these are the important things that are gonna affect livestock in the Northeast as we talk about climate change. And he already mentioned, so I'm gonna skip this. First of all, we looked at forage production and how forage production is gonna be affected by these projected climate changes, increased temperatures, precipitation, decreased snow cover, and all these things that are already covered. I'm not gonna talk about these specific details. I'll summarize for you, but just so you have an idea of what we looked. Elevated temperature, decreased winter soil temperature, for example, these are factors that are going to affect forage production. That, of course, affects livestock production. Less frequent but more intense precipitation and elevated CO2. So elevated atmospheric carbon dioxide is going to affect plant growth. That's also a little controversial, but I left this to the experts in our team to figure it out. So this is the summary of the effects on forage production as we saw it. A reduced snow cover could increase exposure to extreme cold temperature because of the decreased snow cover. Annual forages and whole crop corn, small grains should generally be positive, the trends in this because of the increased temperatures. Forage yield and small grain crops should increase due to elevated CO2. There are some calculations or estimates here that our odds, one of our team members that have done, increased 12, 20 up to 30% in these crops. And also better success with this alternative, if you want cropping systems, no-till cover crop establishment will be affected in a positive way from these trends. So specifically on livestock, animals have what is called a thermoneutral zone. That is anywhere between 5 and 25 degrees. What this means is that if we have lower temperatures than this, animals have to eat more, consume more, expend more energy to cope with these low temperatures. So the maintenance energy needs are going to increase, feed intake will increase, and efficiency of production will decrease. And you will have similar effects on the other side when temperatures are higher than this thermoneutral zone. And that will be due to mostly heat stress. A major effect of this increased temperature specifically will be the effect on dry matter intake. And the opposite of what I just said about lower temperatures, higher temperatures and heat stress decrease dry matter intake. Anytime you have a decreased dry matter intake, you have decreased production. And that's how we calculated these effects that I'm going to talk about here. Just so you know what this looks like, this is the temperature humidity index for dairy cows specifically. You can't see these numbers, but the point is that not just temperature, but humidity is also important in when you calculate heat stress. So these darker colors there, red, purple, they show heat stress at different temperatures and different humidity. So you may still have a relatively lower temperature, but high humidity, and animals can still be under heat stress. This is just one example how we went into these calculations, how we estimated dry matter loss, for example. That's the first equation up there. We used temperature humidity index maximum and threshold, which let's say for dairy cows is 70. And then there was another set of equations to supplement this equation to come up with dry matter loss. I mean, this is basically, I'm showing it to you so you understand that the numbers I'm going to show you later come from this kind of calculations and assumptions. There is a lot of assumptions that go into these projections. There are other potential heat stress effects on dairy cattle. They are physiological, related to reproduction, related to launching an immune response, for example, when there is a challenge, and so on. All these are related to energy expenditures. So again, these are very difficult to estimate or put a dollar value, and we did this, but with a lot of assumptions. So again, you have to understand that there is a lot of uncertainty in all of these calculations. I talked about reproduction, so we also included reproduction. It's typical in dairy cows. Reproduction efficiency drops in the summer with the higher temperatures, and particularly when there is a heat stress. So that's something that you have to account in these projections. Let's say from an average of 20% pregnancy rates down to 15, and this will be a economic loss to the producers. This is a summary of the effects in the dairy sector. Basically reduced production efficiency, lower milk production because of lower dry matter intake, some of these physiological effects that I talked, reduced reproduction, and so on. Here are a couple of examples. So this is average for the Northeast. That comes straight from our paper. So you can see actual numbers of what these effects are going to look like. Different scenarios here from RCP 4.5 to 8.5, the extreme scenario on the right side. So there is additional milk loss line there that I cannot point to you, but you can see it. We estimate as percent of the projected milk production, there will be up to 1% loss in milk due to these changes in climate and temperature. So it's not a huge loss, and it is actually smaller for the different scenarios. Here, there is economic equivalent for that, let's say from 20, 30 up to $80 per cow per year. For the total region, that comes to 125 million in the worst case scenario, lost to the dairy industry because of climate change. Some regions probably will be affected more. This is Lancaster County in Pennsylvania. So as you go south, there will be a great effect of these changes in the temperature. Here, you will have up to 2% loss in milk production. And for that particular county, that comes to about $16, $17 million for the dairy industry. This is on poultry. Poultry is a mixed picture. If I can put this simply here from this slide. First, you have to cool these buildings if temperature is increased. But at the same time, in the winter months, you will have less energy going into heating. All these poultry operations, they're in closed buildings, so that kind of mitigates the effect of increased temperature. So I have to go quickly through those slides because we are running out of time. But again, you can read this in our paper, or you can go through the slides because I'm sure you will have a copy. The beef industry is going to be affected really minimally here, so I'm not going to talk much about that. Equine industry, we could not come up with a good number for the economic impact on the equine industry because it's so diverse and information is not readily available. Small ruminants, again, I'm not going to talk here much, but they are a very small segment of the livestock industries here, and the effect will be quite diverse depending on the type of animal. Manure management, that's actually important. So manure management is going to be affected quite a bit. Depends on what you are looking at. Ammonia emissions versus greenhouse gas emissions, for example. Anytime you have increased temperatures, those emissions are going to increase. So that's the main effect on the manure from our analysis. We also looked at pathogens For small ruminants, for example, this is very important because with increased temperatures, pathogens are going to thrive, and that can affect particularly small ruminants to a larger extent. We also had a mitigation section that I probably don't have much time to go into, but there are some mitigation options on the nutrition side and manure management side as well. And again, you can find these things in the paper. I have some of these mitigation options here, but I'm going to skip them. These are our conclusions. Not have time to read it. I will summarize it in one word. We thought that the effect of the projected climate changes on the animal industry is going to be minimal. The dairy, as the largest industry, we estimate about 1, maybe 2% decrease in milk production. There will be some physiological effects that we cannot estimate or cannot put a dollar number to it. The poultry industry will be a wash, basically, as I said here, and the other industries are not going to be really affected much. Manure emissions probably will be increased overall. So I guess I fit in the time. That's all I had. Thank you.
This might be a question for Art and David and yourself. One of the disconcerting analyses that came out of David and Art's paper, you touched on, was temperature. Out of our paper, it was particularly nighttime temperature. The planetary boundary layer, I think we're just getting into that, but it seems like the projections for nighttime temperatures are going to be about double the global average temperatures. So could you speak to the ramifications of what increased nighttime temperatures will be on the animal industry?
Yeah, okay, I can talk only about the animal industry, and I'm not even sure that, what the increase is there. But there is no heat stress at night in the animal industry. So I don't think this is going to affect large animals. If we talk about poultry, again, poultry buildings are climatically controlled. So if there is an increase above certain level, that may require more energy to cool down the building. But in general, I think night temperature are not going to affect the animal to any significant extent. It will probably affect forage production, and probably it will be positive unless you have exposure to colder nights. But on livestock, I don't think it will have any significant effect.
Just something on crops. So I think the night temperatures. I can first think about nighttime respiration.
Yeah.
Nighttime respiration reducing daily cumulative carbon and dry mass increase. There's some cases where the nighttime temperatures, though, will increase the degree day accumulation, make plants develop faster. In some cases, it might be seen as a positive. But the main thing would be, potential for dry matter losses or slower growth due to those losses. And there are crop models and such that can assess that. We didn't really look at that in a lot of detail in our study. But if you do look at crop modeling study using some key models that might provide some qualitative analysis of that sort of thing. So that's a good point.
So I have a discussion. What's your opinion about future change in livestock farming?
One point I had there that I didn't mention much is we think that these changes are going to accelerate the enlargement of dairy farms, for example. So smaller farms will go out of business because they have to do additional things to cope maybe with these small changes. And also reduce production. But if that's what your question is about, I think we'll see more and more larger farms versus smaller farms.
How about regional sheep? Do you think
Yeah, good point. The regional shift, because of this climate change in the Northeast, I don't think it's going to take place. Regional shifts are taking place right now because of other factors. In particular in the dairy industry that I'm familiar with, farms are moving actually back to the Midwest, for example, but I don't think this is going to affect that trends.
Alex, consider some of our grazing operations in your study and the effects that they might experience?
Yeah, excellent point. There is a lot of grazing dairies in the Northeast, these organic dairies that you have, they have a requirement for grazing. This will depend heavily on the effect on forage production. So if, our estimates for forage production is that will probably be either a beneficial or a wash effect. So, in that aspect, I think we may actually have an increase in forage production, and that will benefit grazing. One other point that people made in our paper was that increased precipitations, for example, may have a negative impact because trumping the pastures and need for shelters and these kind of things. But on the forage growth side, I think it will be a positive overall trend. Yeah.
So another aspect of climate change, as we heard from previous presentations, frequent storms or high precipitation. As a result, hydrologic cycle and runoff will increase. So what kind of impact that actually has also on animal systems, dairy or otherwise, for waste management, that from loafing grounds, that open outdoor farming, that extreme runoff events can actually wash a lot of nutrients into the water system. So environmental aspects of it is another policy issues that our farmers have to deal with. Did you all look at those aspects of impact?
Yeah, again, very good point that relates to manure management. I think what our conclusion was, because of the increased temperature, we project increased ammonia losses, ammonia volatilization. And that will actually reduce the remaining nitrogen in manure. So even with increased precipitations, you may see a lower leaching, nitrogen leaching, and phosphorus as well, compared to the current state. So ammonia volatilization will increase and there will be less nitrogen. On the nitrous oxide side, we actually projected that there will be increased emissions of nitrous oxide because that all relates to soil moisture. And if you have increased soil moisture, you will have increased nitrous oxide. Yep.
I think we'll finish it off here, but please join me in thanking Alex Rustoff.
Yep.